Alrighty guys, so this is the big lesson for this unit. Solving systems of equations in 3 variables. So with this system of equations, we have 3 equations, and these equations all have 3 variables. So we're going to use the same skills that we have used before for these other equations with only 2 variables and 2 equations, but it's going to look a little bit differently because we've now got 3 equations and they have 3 variables. So we're going to be using elimination for the most part with solving systems of equations with 3 variables. And if I look at all the variables, like if I look at the x's, none of those really seem like they're set up to cancel out automatically. Same thing with the y's, none of those would cancel out, or the z's, none of them would cancel out. So we're going to have to do a little bit of multiplication in order to get this system ready to eliminate. So what they did here, step 1, they said, since the x in equation 1 has a coefficient of 1, so this one here, we're going to choose that one as like the working equation, the one that we're going to work with. And if I wanted to cancel that out with the 2x that we see here, I would need to multiply this equation by -2. So if I do that, we would get -2x plus 4y minus 10z equals a positive 14. And that's what they have right down here, is when they multiplied the equation 1 by -2. So then we can add that with the equation 2. So this 2x plus 3y minus 4z equals 14. I'm right there. Then they're set up to eliminate because the -2x and the 2x would cancel out. The 4y and 3y would make 7y. The -10z and -4z would make -14z. And then 14 and 14 makes 28. Okay, so now we have this equation where we've eliminated the x from the equation. So it helps us out a little bit because now we've got one equation that's only got 2 variables, but we need to get another equation with 2 variables so that way we can solve it the same way that we've solved our other equations. So what we could do is we can go back up to that first equation, and this time, let's say I want to cancel it out with the 3x minus 5y plus z. Well, then I would need to multiply this equation by -3. And that would give me -3x plus 6y minus 5z equals 21, which is what they have right down here. And then if I were to add it with that other equation, right, we could now add these 2 together. Well, then the -3x and 3x cancel out. 6y and -5y make y. And the -15z and z make -14z. And then the 21 and the 7 make 28. Okay. So now we have 2 equations. 7y minus 14z equals 28. And y minus 14z equals 28. So these 2 equations are what we're going to be working with going forward. We're going to solve this system of equations just like we have all the other ones. So we can use elimination with this one as well. If we multiply, let's say, the first equation by -1, that would give me this -7z plus -7y plus 14z equals -28. Then we'd be able to combine that with the y minus 14z equals 28, so that the 14z and the minus 14z would cancel out. -7y plus y would be -6y, and -28 plus 28 would be 0. So we get -6y equals 0. Divide both sides by 6, and we now know that y equals 0. And now that we know that y equals 0, just as we've done before, we can take that and substitute it back into one of the equations. So it looks like they substitute that into this equation right here to say that for y, it would be 0 minus 14z equals 28. That cancels itself out. Divide by negative 14. And now we know that z equals negative 2. So now we've got 2/3 of our answer. We now know that y equals 0 and that z equals negative 2. So now we can go all the way back to our original 3 equations, the ones we started with way up here. And we can now use both the numbers for y and for z into one of the equations. So it looks like they take the first equation here, and they're going to substitute in y equals 0 and z equals negative 2. So here they put in y equals 0, put in z equals negative 2, and they solve for x. So the 2 times 0 is 0. The 5 times negative 2 is negative 10. So that gives you x minus 10 equals negative 7. Add 10 to both sides, and that gives you that x equals 3. So the rest of this formatting is a little bit differently than what we're going to do. But the system will meet at this point 3, 0, negative 2, because x is 3, y is 0, and z is negative 2.